All right. So we explained the performance consideration of Python. As we explained, uh, when it comes to executing code, there are two main methods, interpretation and compilation. So let's briefly look at these. First, we have interpreters. An interpreter is a program that reads your code executed directly line by line. It's like having someone read a recipe and immediately perform each step as they go along. So on the other hand, we have compilers. A compiler is a program that takes your entire source code and translates it all at once into machine code that can be directly executed by computer. It's like translating an entire recipe book from one language to another before you start cooking. So both of these methods, compilers and interpreters, they have their pros and cons. This chart that you'll see here summarizes some of these advantages and disadvantages. For example, interpreted languages often provide more immediate feedback, while compiler language can offer faster execution speed. In the context of the data science, Python, the language we're using is primarily an interpreted language. This will give us some advantages in terms of ease of use and flexibility, which are very useful when working with data. So for now, the key thing to remember is that when you run Python code, it's being interpreted line by line. This allows for interactive and dynamic coding styles that make Python so popular in data science. All right, now let's take a look at some essential libraries and features of data science now that we have an understanding of basics and how Python fits into data analysis and data science. Let's shift our focus to exploring essential libraries of Python. The first library that I would like to discuss is NumPy. So NumPy is short for numerical Python. NumPy is very important in numerical computing. It provides multi-dimensional arrays, element-wise computations, linear algebra, and more. It's foundation for many scientific applications. So as we said, NumPy is short for numerical Python. It is fast, efficient, and it does element-wise computations and mathematical operations. It's a great tool for reading and writing array-based data sets. Okay, now let's look at a particular example using NumPy, one of the fundamental libraries for scientific computing in Python. But before I write the code, please don't worry if you don't understand the code at all. We will break it down step by step. So first, let's import the essential library in order to use NumPy. Let's import NumPy library. So this line essentially tells Python that we want to use NumPy. And we are giving it a shorter name, NP, for convenience. So next, I would like to create a two-dimensional array. Think of an array as a table of numbers. Okay. Here, I am creating a table with 2 rows and 3 columns. The first row is 1, 2, 3, and the second row is 4, 5, 6. When we print this array, it will look like this. Now, let's do something interesting with this array. This is where NumPy really shines. With just one simple operation, we can multiply every numbers in our array. Let's multiply our array by the value 2. Okay, so we've multiplied every numbers in our array by 2. Now, let's see the result and see how every number has been doubled. So this is called an element-wise operation. It is very efficient in NumPy. Now let's calculate the mean average of each column. So to do that, so the np.mean, it's a function that calculates the average. We will later explain what is a function. For now, just accept it as function. The axis equal to 0 parameter, it tells us that it tells, NumPy to calculate along the columns. And the result will be, we do Shift Enter to execute. So this means the average of the first column, 1 and 4, is 2.5. The average of the second column, 2 and 5, is 3.5. And the average of the third column, 3 and 6, is 4.5. Right, so as we progress in this course, you will become really comfortable with these operations, and you'll see how they can be applied into real-world data analysis tasks, hopefully. Right, any question? So now let's move on to pandas. Another library of Python. So panda's name is derived from panel data. It's a powerful library for data analysis. Panda really offers a high-level data structure like data frames and series, which we will explain throughout the course. It's designed for structured data manipulation, analysis, and cleaning. So in pandas, we have data frames and series. Just to be familiar with these concepts, data frame is a tabular column-oriented data structure with both row and column labels. And a series is a one-dimensional labeled array object. All right. So Panda is a versatile library for data manipulation and analysis in Python. Its data frame and series, like the series object, they serve as a powerful tool for handling data that are structured. Remember that. We said that throughout this course, we will be only focusing on structured data. Now let's look at a basic example. Using pandas. So first, we import pandas. Just like what we did with NumPy, we're giving pandas a shorter name, P.d, for convenience. Next, we're going to create what is called a data frame. Like we said, data frame is like a table or a spreadsheet. So here, let's create a simple data set with 3 columns. With name, age, and city. Each row here represents a percent. So when we print this data frame, it will look like, let's print it. It will look like this. So this gives us a quick summary of age data. It shows us the count number of values, mean, which is the average, standard deviation, which is a measure of spread, mean, max, and quartiles, like 25%, 50%, and 70%. Sorry, I forgot to write that line. So this line, again, gives us a quick summary of age data, right? It shows us the count, number of values, mean, standard deviation, which is a measure of spread of our data, right? Min, max of our data, 20, 50, and 75%, which are quartiles of our data set. So now let's filter this data. And this line, we would like to ask pandas to show us only where the age is greater than a certain number, say 28. So if we do that, the result will be like this. So see how it only shows Bob and Charlie, who are both older than 28, 30, and 35. In just a few lines of code, we've created a structured data set, computed summary statistics, and filtered data based on a condition. So this demonstrates the power of pandas for handling and analyzing structured data. Moving forward, let's talk about pandas visualization libraries like Matplotlib. Okay. Matplotlib is the to-go library for two-dimensional data visualization. It is widely used for creating plots and suitable for publications. It gives us high-quality visualization for data analysis, and it integrates well with Python ecosystem. So now let's walk you through an example with Matplotlib. So as usual, we import the necessary libraries. This example, we're going to be using NumPy library as well as Matplotlib. So we will first import Matplotlib as PLT for short. And we're also use NumPy as NP to help generate our data. Next, we create our data. Let's generate some data. So here we will be using, we are using NumPy to create two arrays. X is a sequence of 100 numbers evenly spaced between 0 and 10. And Y is the sign of each number in X. So this will give us the points for our sine wave. Now let's create the plot. So this is where the magic happens. So we are telling Matplotlib to create a line plot using our X and Y data. Here it is. Okay. So now we can, the label, if we use the label, we can label in order to produce legends as well as title. So by this line of code, we will provide a title, a simple sine wave, and then this will generate, adds and generates legend to our plots, which will show the label we defined. This. So we define the labels here, right? Then we generate, so this line will generate the legend. So we can also add this line, which adds a grid to our plot, which makes it easier to read the values. And then we'll ask to show the plot. Okay, this displays the plot we created. when you run this code, you will see a smooth curve that goes up and down. That's our sinus wave. The x-axis shows the input values from 0 to 10, and the y-axis shows the sign of these values, which always stays between -1 and 1. So this simple example demonstrates the basics of creating a plot with Matplotlib. So as we move forward in our class, we will learn how to create more complex visualization and customize them to effectively communicate our data insight. So the next library that we will discuss is SciPy. SciPy addresses foundational problems in scientific computing. It includes numerical integration, linear algebra, optimization, and more. It's an essential package for scientific computing, right? And as we said, it includes integration, optimization, signal processing, etc., etc. The next library that we're going to learn is scikit-learn. Scikit-learn is a machine learning toolkit. It includes classification, regression, clustering, and more. So it's a general purpose machine library, which is helpful for classification, regression, clustering, and dimensional reduction. We then have stat models. Stat models is a statistical analysis package for classical statistics. It includes regression models, time series analysis, and more. So it focuses on statistical inference and analysis. It includes regression models, ANOVA, time series, and analysis. So Python's ecosystem of essential libraries, like what we explained here, is a to-go choice for data analysis and scientific computations. So in our next class, we will try to go over an example with these 3 libraries that we explained here.